Hi, it's T here, and today the video that I'm going to make is a lot different from the typical DIY video that this channel presents. It's about math and numbers. And so, anyway, here goes. I've always liked numbers, not necessarily math per se, but I've always liked numbers, and I've always had real ability to remember numbers, even if they're very long. I remember all the telephone numbers my family ever had, that I've ever had, including the first house that we lived in. I remember the post box number that my parents had when I was a very small child. I just really like numbers. Some people, stereotypically female, when they're saying, oh, that's and they see things in colors, or they see things as male and female, I identify with inanimate objects. Instead of giving it a color or a gender, I give it a number. So, background there. I do like numbers. So, 10 years ago, I was breastfeeding my child. It was the last feed of the night. The room is dark. There's really nothing for the person to do if you're the one being breastfeeding. So I was laying there, and my baby was a bit fussy, and it was taking longer than usual. And so I decided to do my times tables. And so I went all the way up to 12, and the baby was still fussing a bit. So I thought to myself, you know, what am I going to do now? So I decided, okay, I'll go back through the times tables, starting with 2s. 1's too easy, obvious. I'll go back, and what I'll do is I'll take the answers that I have for each answer, and I'm going to add them together, just for fun. So for example, 2 times 6 is 12. 1 plus 2 up to 12. 1 plus 2 is 3. 2 times 7 is 14. The 1 plus the 4 is the 5. Okay, so what I'm going to do is I'm going to turn off the camera, and I'm going to show you what I found. As I said, this was 10 years ago, and I've told a few people, and they were kind of, oh yeah. But to me, I think this is really fascinating. So my husband said recently, why don't you make a YouTube video about it? So that's what I'm doing. So I'm going to turn off the camera, and I'm going to show you this piece of paper to better explain what I came across. All right. So how to do this without casting a shadow. So here are the 2 times tables, and everything is done from 2 times up to 12 times. And so 2 times 2 is 4. 2 times 3 is 6, right, moving on. Okay, double digits here. All right, so what I've done with here we go. So for the first one, 2 times 5 is 10. 1 plus 0 of the 10 is 1. And then here we go, 2 times 6 is 12. The 1 plus the 2 is the 3, okay? So anyway, I'm not going to go through it all with you. So the point I'm trying to show you here, what I want to show you is the pattern. 2, 4, 6, 1, 3, 5, 7, 9, 2, 4, 6. And if you continue on, this exact pattern will continue. That's the point of this video. Every multiplication combination has a pattern, and I think that is absolutely fascinating. This one, for example, for the 2 times tables, it goes even numbers, odd numbers, even numbers, odd numbers, even numbers. So moving on to the 3 times table. Oops. Here we go. 6, 9, 3, 6, 9, 3, 6, 9, 3, 6, 9, 3. This will go on into infinity. I hope I've explained the initial part correctly so that you can follow along. Yeah, all right. So 3 times 2 is 6. All right. 3 times 3 is 9. 3 times 4 is 12. 1 plus the 2 of the 12 is 3. Okay, so just keep going. So 4 times table, the pattern is 8, 3, 7, 2, 6, 1, 5, 9, 4, 8, 3. So you see this? 8, 7, 6, 5, 4, 3. And then you see here 3, 2, 1, 9, wait a minute, I've got enough time there. So in some of them, even the answers, they have ascending order and descending all in the same pattern. Moving on, you've got 1, 6, 2, 7, 3, 8, 4, 9, 5, 1, 6. Okay, so you've got 2 evens, 2 odds, 2 evens, 2 odds, 2 evens. So you can look at this and you can see all kinds of fascinating things in here. The 6 times table, 3, 6, 9, 3, 9, 6, 3, 9, 6, 3, 9, 6, and you say to yourself, hang on a second. Very similar to this one, but it's actually flipped. So the 3 and the 6 have the same pattern, numbers anyway, but it's flipped. Okay. So this is just going on. So 5, 3, 1, 8, 6, 4, 2, 9. So again, we've got a combination of odd numbers, then 4 sequence of even numbers, 4 sequence of odd numbers. It's just fascinating. So 8, 8 times table. Okay, I'm not going to explain the whole thing. I just want to briefly, quickly get through this. Here's the 9. Here's the 10, the 11, and the 12. Now, if you keep going further, so on this piece of paper, just to demonstrate, I've done 13, 14, 15, 16, the times tables, okay? So 14 times 1, 14 times 2. Now, the really cool thing, another cool thing that I found was, okay, so this is a 16 timetable. So 16 times 2, 16 times 3. And these are the answers when they're added up. But watch this, okay? See this? 5, 3, 1, 8, 6, 4, 2. Now, you say to yourself, hang on a tick. She just pointed that out. There's a sequence of 4 odds, 4 evens, 4 odds. That's right. Check this out. See, this is the 16 times table, okay? What is 1 plus 6? All right, so it's 7. So if you move up to the 7 times table, it's the exact same pattern. Let's move down here. 14 times table. 1 plus 4 is what? 5. So what I found was you can take any number, add it up, and bring it down to one single digit, and you will find that the pattern of that multiple is the exact same as a single digit pattern. So for example, 1 plus 4 is 5. So here's our, for the 14 times table, here's our pattern. 1, 6, 2, 7, okay? So again, 1 plus 4 is 5. Let's move up. Oops. 1, 6, 2, 7, 3, 8, 4. It's the exact same pattern for the 5. For the 5 and that. Okay, so anyway, moving on. So here I've done with the 23 times table. Okay, so just to show you, so 2 plus 3 equals 5, and here's that same pattern again. Now I thought, okay, I'm going to take a really huge number just to see if it still works. So here's 42,953. So if you add all these digits together, it comes to 23. 2 plus 3 equals 5. And again, 5, the exact same pattern. I just think this is absolutely fascinating. So another thing I did was, then I moved on and I took the 42,953 multiplication table, and what I did was I took these answers, okay, because what I was trying to do, so this is 42,953 times 1 times 2 times 3, and these are the answers, okay? And what I'm trying to do was I was trying to get it down to, could I see a pattern, a number that would represent each answer, and because it's the same starting off point, it's the same number being multiplied, would there be a pattern in that? So for example, 42,953, the answer here would be 9. Because if you use all the numbers, so 4 plus 2 plus 3 is 9, the 5 plus 4 is 9, and then the 9 is 9. Okay, so the common number here and the answer would be 9. Then I moved on and I said, okay, 2 times 42,953 is 85,906. What would be the common number here, adding these up, yeah? So I said, okay, the answer would be 14 because I'm using all the numbers. 8 plus 6 is 14. 9 plus 5 is 14, and the 0 obviously is not going to be used. So I just did that, and yeah, I think it's fascinating. And I've actually searched on YouTube and Google to find math patterns, anything like this, and I haven't seen anything. So my husband said, make the video, share it with people. So I hope you understood that, and I hope you enjoyed it.